And this afternoon, we are lucky to have HP as our presenter. They'll be talking about their new helium technology, which is hasn't really quite hit the market yet, so we're going to get a preview. So this is going to be pretty exciting. On the phone, I have Jambey Clinkscales. He is going to be our primary presenter. Jambey has more than 35 years in technology in the industry with demonstrated leaderships. He has progressed on hands-on network engineering roles to regional and executive management, serving as the client delivery executive and account manager in the global financial markets group in New York. Jambey is a problem solver who's improved technical operations in alignment with strategy, business planning, direction. In his current role at HP as a senior consultant manager for the American Project Services Consulting Team, as a leader of the cloud technology, application contexting and emerging technology, Jambey's group is responsible for consulting across HP customers base on cloud strategy and services. The team also provides application services as part of the migration service. This team also leads the application sustainable mapping of cloud, engaging while helping clients assess their application portfolios match the particular deployment models of cloud services. Previously, he joined the IMAD team. He was a emergent account for HP as a PMO and host lead. As a program manager, he has led several virtualization projects as well as enterprise upgrades for Exchange 2010, Active Director, Service Center, Configuration Management. In 2010, Jambey worked on the HP Clement account, coordinating all the plans for a data center consolidation project. He was also in the American Web hosting transformation of the Unevable Global Enterprise Computing Transformation Program, where his team was responsible for moving all the promotion and production websites from Unleave and data center Trumbull, Connecticut, into the HP Next Generation Data Center in Alpharetta and Swami, Georgia. In 1999, Jambey became the chairman of the HP Black Employee Network and established the annual Black History Month webcast featuring African American IT executives of HP as a keynote speaker. Jambey is a member of the Atlanta chapter of Black Data Processing Associates, a global membership organization focused on providing professional growth and technical development for African Americans in IT industry through education, mentoring, service, and business network. Jambey has been married to Gwen for 34 years, has 3 children and 7 grandchildren. In 2010, he relocated from New York to Atlanta, where he serves as the board of director for the Annistown Metals Homeowners Association. They're in trouble. And thank you. And this is, we also have that will be presenting with Jambey, Matt Farina. Sorry, thank you, Matt. Matt is a HP master technologist, and he has been the technical lead for the HP Helion development experience and the HP public cloud market. He's built applications on OpenStack Cloud Foundry for over 3 years. A programmer since elementary school, Matt has written software in numerous programming languages, spoken at conferences, and is published. Thank you. So I will turn it over to Jambey and to Matt.
Hello, this is Jambey. Can you hear me? Thank you, Beverly, for that outstanding introduction. Hey, Matt, how are you, my brother?
I'm good. How are you?
All right, thanks for being there in the room as we tag team through this. We're going to move through the presentation quickly. We got a couple of things that we want to talk about with you today, and I'm looking for my screen to change here. There we go. And the agenda, as you see in front of you, will start out a little foundational information about cloud. I'll talk to you what OpenStack really is, and then Matt will take us through the HP Helion portfolio, and then I'll come back and give you a little bit about the professional services team supporting the HP OpenStack. Now, although I call this Cloud 101, I'd like to think about the basics of cloud as Cloud 3, 4, 5. And pay attention because there will be a verbal test. And I always think that the three service models are pretty easy to remember. People know about the infrastructure as a service, platform as a service, and software as a service. And you hear a lot about the two deployment models of private and public cloud, but there are two more, community and hybrid. We hear about hybrid, but not as much about community. The thing I'd like to share with everyone is to remember that there are 5 characteristics that make up a cloud service. The ones that most people think about is the fourth one on our list, the rapid elasticity, the ability to scale up and scale down quickly. But all of them are important aspects. It has to have that on-demand, self-service nature so you can get to it and order things on your own, broad network access and mobile access, and that the advantages have to be built on a pool of resources. So those are the 5 characteristics, the 4 deployment models, and the 3 service models. Cloud 3, 4, 5. We spend a little bit more time on the service models because as we look at the 3 of them here on this slide, the IaaS, infrastructure as a service, is the type of service that OpenStack provides. And OpenStack gives you the ability to have massively scalable infrastructure as a service. And you see some of the names on the right, which are typical applications when you go up from infrastructure as a service, and folks have heard about the Amazon cloud, and then up at the top, the software as a service, the Salesforce.com, which HP and many large enterprises are using today. The reason we show this slide is it gives you a feel for the difference between the service models. So on the left, the column is when you sort of run your environment and run your services yourself. And then as you move over into the second column from the left, where infrastructure is shared, so that's your IaaS, infrastructure as a service. And then you move over to the next 2, which are versions of platform as a service. And then the one on the right is software as a service, where data, application, and platform and infrastructure are all supported by the service provider. We take another look at that same model, but now we break out some of the details. Many of you are involved in some of these aspects of getting an application and its service up and running, starting with the network team, up to storage through virtualization, up to the middleware and runtime into the application at the top. And that's on-premise, and as you see, in a traditional environment, you manage all of that. But as we move into the infrastructure, platform, and software as a service, you can see that the service provider takes on management of those functions within your stack. Now, in many cases, if this was talking about a Windows server and Windows application, this would be closed because the Windows environment would define all of the networking servers, all of the modules in your stack are defined by Microsoft as their proprietary. That's the difference with open source OpenStack. It's open to a large community of people to get the best-in-class features and functions in each one of the elements within the stack. And here's a view of some of the well-known names in the infrastructure, platform as a service, and software as a service. We saw a few more, but here are the ones that are the logos that go with them. And we brought in a industry definition of cloud, and everyone has heard about Gartner. Gartner defines cloud computing as a style of computing where scalable and elastic IT-related capabilities are provided as a service. And Matt will talk to you more about the concept of everything as a service. That's the key element of cloud. And this provides customers, this service is provided to customers using internet technologies. That's the Gartner definition. This is just another view. I like this slide. And it shows you, if you look at the globe, where some of these things fit. And one of the things that's unique about this view is that it has a communications and social applications layer on the top. This is the cloud stratosphere view from infographic. We'll spend a few minutes about the types of applications that have been traditionally considered best suitable for the cloud service model and the benefits that they get from using a cloud model. So you see here the comparisons between the compute requirements over time. We have the on and off, so when you have the inactive periods, you can kind of shut down and reduce your utilization and cost. The fast growing ones are important because you cannot always, in a traditional model, get your new service up quick enough to respond to fast growing demand. Cloud can do that for you. The other ones are the two on the bottom, the bursting, where over a period of time you have a spike in demand, but then over the short period of time that demand goes away. With a traditional environment, it's difficult to get your infrastructure to scale to meet that bursting demand. So these are a couple of slides we put in here. We want to set the basis on what cloud services are all about. So before we go into OpenStack, I'm actually going to have some audience participation. Beverly, can the audience hear me well?
Yes, very well.
Okay, great. So I'd like somebody to tell me what Cloud 345 is about. We have any takers in the audience? So I see somebody, and I don't really, but somebody sitting in one of the front rows on the right-hand side.
That's Matt.
What is Cloud 345?
345.
I'll help you out with the first one here. 3 service models. What's the 4 and the 5?
3 service models.
You went too fast, man.
Yeah, platform,
Platform. I don't know.
infrastructure, and software as a service.
There it is. 4 deployment models and 5 characteristics. Got it?
Don't feel bad. I couldn't have.
All right. I wanted to make sure people were listening and try to make this as interactive. Beverly, I also want you and Matt to let me know if there's any questions as we go through this.
Okay. Just
All
raise
right.
your hand.
So I'm sure many of you have heard of OpenStack. And when I first started hearing about it, I kind of wondered, well, what does OpenStack mean? And you can get a lot of different definitions of what parts are open and what is the stack. But this comes right off of their website. And, you know, it talks about open source. The design is open as well as development because you have many companies that participate in it and they contribute to the overall solution. The long-term vision of OpenStack is to produce a ubiquitous open source infrastructure as a service. We talked about that. That's one of our service models. The technology behind OpenStack consists of a series of interrelated projects delivering various components for a cloud infrastructure solution. And we're going to take a look at some of those projects and the components that are part of the OpenStack Cloud system. And that's the official symbol on the upper right of OpenStack, and you can see that it's trademarked. So if you go to the www.openstack.org/software, you'll see this picture of a basic OpenStack installation, and the three components you see are the compute component, which is your virtual machine that actually provides your servers, the networking so that the servers can talk to each other, and then the storage. And there's a couple of different ways you can look at storage, object storage as well as block storage. And then your applications sit on top, that's in the gray box. And then there is an OpenStack dashboard as the basics. And then you can see there are other modules if you went to this page today, you would see other modules that would drill down into the various components. On the bottom right, you can watch a little video on the latest release of OpenStack, which is called House. We're going to take a look at how the versions of OpenStack are named. They're named like hurricanes are named, different names, but in alphabetical order. And then on the left side, we see another definition. OpenStack is a cloud operating system that controls large pools of compute, storage, and networking resources throughout a data center, all managed through a dashboard that gives administrators control, while empowering their users to provision resources through a web interface. So please, if you have not, go out to www.openstack.org. Now, we mentioned that there are many components, and this view gives you the architectural view. So the portal is the place that can give you a view of your entire system. You see on the left that you have your network, which is the virtual network. You have your block storage, where your files can be in a repository. You have the compute in the middle, which is that virtual machine function. Identity at the bottom is the same thing as we all know, the functions that Active Directory provide in our current Windows world today. You can store an entire image, a server that has been used or will be used multiple times, and you can name different images and pull them up for web-facing or for databases or whatever that image is for. And you can put a blob, which is just a bunch of data in one place, and that will be relevant when you start talking Hadoop and big data. So this is an architectural concept.
Yeah,
We go a little deeper
Just a
now
second,
and
just a
see
second.
how.
Jambey?
Yeah, questions?
Yeah, just a second. Go ahead. I do
You
have
gotta
a
log in.
question.
You
I
gotta
got
log
one in?
Yeah.
Okay.
Yeah, it was so quick that once you passed it.
Okay. I have a question. I'm trying to put this in context of what I understand. I am a past mainframer, so my learning is based on coming up in a mainframe environment. Can you kind of relate what we're seeing now to what would this replace in the old technology? What technology did this replace, and what would this look like in the way we're used to seeing it, or the way we used to see it? Would it be some physical servers and software, or is this a virtualization taken to a whole nother level? I'm just trying to.
So let me take one crack and then I'd like to hear your answer as well, Matt, okay? So, Beverly, that was you, Beverly, right?
Yes.
So I would compare cloud in general to mainframe, and one of the aspects that is common is the fact that you have a shared resource pool. So you remember and I'm not really a true mainframer, but I know that in mainframes, I think some of the division was based on, is it LPARs, is that right?
Yeah.
And you could kind of partition those off and have different applications run in different spaces. So you have that similar aspect here because what virtualization has done for us, and there's virtualization everywhere, it's allowed us to abstract from that hardware, and you can share. So cloud and virtualization have the ability to share, and you do the same thing in mainframe, and I think that's one of the things that's common between mainframe and OpenStack. One of the things that's different is that all mainframes were proprietary, right? There was no open source mainframe. You had IBM, and I guess there were a few others that built it, and everything in the stack that made it run was done by IBM. Nobody else contributed to it. That's my short answer. Matt, do you have anything else to add to that?
Sure. You know, when you think about computing, if you went back 20 years ago and you looked at a network center, you'd have big servers in there that had a little bit of computing power. And then if you went, a decade later, you'd have a lot more servers. And if you went, even 5, 6, 7 years ago, you'd have a data center that was maybe 20 times the size of the decade before. But things are growing at an exponential rate. So how do you manage all of those resources? You can't have somebody go and physically plug everything in, install the software in each individual one. If I want to spin up lots of servers, and our applications take advantage of this, right? So an application that does some big data, or takes a big data set and runs a bunch of analysis on it, it might take the computing power of 20, 50, or 100 computers, and you might only use that for an hour. And so you want to get these, you want it fast, you want it to do everything, and you want those resources to go away. When I was doing enterprise work a decade ago, I remember I had to get a server. It took about 2 weeks to get it, and then I would use that an hour a night to run some jobs, and the rest of the day it had to sit there idle. But it had to have enough power for that hour a night. And now everybody does this. You get into these big data centers, and yet we want to crunch more and more data and do more and more with it. So we end up with these giant shared resource pools via the cloud. And it's not just resource, because we talk about compute a lot in this, which is your computing power. You can quickly get a server in seconds or a minute based on an image that you did before. You can snapshot, start from scratch. You can do all these things to give you the flexibility in being fast. So we can deal with large data sets, large resource pools, but you also get other things like storage. So I bring in all this processing work. While, in the past I'd have to have a server with a huge array stuck to it for me and everybody else, which is to hold all of this data. No, just stick it in blob storage. We got a service that just handles it for you. You need load balancers. That's something that's not up here. Oh, when you used to do a data center, if I had a service and I wanted to go out and do something, everybody who did anything would have to go get their own, a net scaler or some kind of load balancers, their servers, and do all of it. Well, if a company just had a cloud, or you go with a public cloud, then you just order it up as a service, and rather than taking days or weeks to get it set up, you get it set up in minutes, and you're off and running. And so you can try new things. There's all kinds, it basically takes the infrastructure workload that so many people had to do, compress it down into the people who run the cloud, and then let everybody else take advantage of it. And since we're dealing with, more applications, more data, more of everything, it allows us to have a shared resource. Another way to think about this is power grid, right? Think of it as a power grid. Lots of people used to generate their own power. You go back 100 years ago, people would have generators. Now nobody does. We just plug into the power grid and it's a shared resource. And some companies and some organizations will do it, but even within there, it's a shared resource. Because not everybody, you have to come up with a peak workload for everybody who uses it. Not everybody has to deal with their own peak workload. And so this gives us the ability to share resources and only have to deal with peak workloads in a company, in either or public cloud. and give us a lot of this scale that's exponentially larger than it's ever been, and be able to manage those resources and utilize them really quickly. And so that's kind of where this transformation is.
What's the difference between virtualization and cloud?
In this sense here, it's the scale and speed at which you can do things. If I want 500 servers that are, 8 cores, 16 gigs of RAM, all of this, I'll get those in a few minutes. All ready to go, booted up to an image that I pre-chose, ready to go. It's virtualization that's fast and at scale in ways that we didn't have before. I mean, if I wanted 500 of those, just like a couple of minutes, and all of a sudden they're all at even to go interact with each of those, you've got to automate those things as well. But there's lots of workloads where you would do it that scale. And you can really take advantage of that.
So isn't virtualization kind of one of the components of the cloud in a sense?
It really
That
is.
the cloud sits on top of virtualization.
And yeah, and in fact, the compute technology, it actually sits on known hardened virtualization technologies. It's not like these are new virtualization technologies. It's a layer of management on top of existing virtualization technologies.
So what makes virtualization possible is the memory capacity?
The memory, the cores, all the machines networked together, and the ability to move workloads around.
But they're no longer physical machines.
Yeah, everything you get. Well, that depends. One of the services we're going to talk about goes beyond virtual. So it can be virtual or physical machines. So I won't steal some of the thunder from
Okay.
that. That's one of the services is actually using this to deal with physical hardware, because that's one of the things with virtualization is you have that virtual hardware layer. You lose something in that. So some people want to get to actual hardware machines, and a new thing you'll hear talked about now is even something called Docker, which isn't part of this, but I'll be happy to talk about afterwards. And so there's other technologies coming to figure out how do you get more power of the actual hardware in there as well. And OpenStack has answers for that. Did that answer the question?
One way to consider looking at that is as you make a request for those resources that you need to do a certain task.
So I can't hear anything.
Sorry, I'll speak up. Another way to think about it is as you request those resources, the amount of time it takes for you to, in the old IT paradigm, to order that equipment, to bring it in, to build it up, to get it on site, to get it up and running with your image, to actually execute along that line. I've seen customers that have reduced that amount of time from 55 days to 5 hours for a large scale kind of a rollout along that line. And that still included the bureaucracy of them getting the approvals for them to go ahead and do what they needed to do. So it's a real world example of saving time. And when the project is done, those resources get put back into the pool for other groups to take advantage of. So instead of having to buy all of these assets in order for them to have that to accomplish a task, and then they have a 3-year lease or whatever attached to that hardware, it's a shared resource. You put it back into the pool and somebody else can grab it as needed.
Okay. So I guess we're still saying that well, I don't want to steal the thunder, but the physical doesn't exist anymore.
It doesn't matter.
It doesn't matter.
Right.
Wow.
Right.
You still have a physical interface to the real world.
Yeah.
We haven't figured out how to make software just run by itself. Just have code execute.
But there are different paradigms on how that either you own that equipment or you get it as a service.
Right.
Or both.
Or both, or a hybrid, or a combination of the two.
Okay. Okay. I'm good for now. Thank you. Okay, any other questions? Anybody? Okay. Here you go. You can continue, Jambey.
Oh, okay, great. Thank you for the question, and thank you for your answer, Matt. So keep this architecture concept in mind. It's a good view. We're going to get a couple of deeper versions, but it's basically the same architectural concept. So now you see names on the screen that are functions, right? Compute, network, block, identity, and portal. Now we're going to look at a drawing that is a version of OpenStack called Farina, and now you can see some of the actual features and the flow within each one of those. So don't get lost in the boxes and the drawings. But it's basically the same stuff. At the bottom is the identity feature in OpenStack Identity Service. On the right is the networking feature, the block storage, compute, as well as the image service and object storage. And Horizon is the name of the portal that comes with OpenStack. And then if we looked at this eye chart, this shows this one to you to let you know and see some of the flows and interaction between the services. And we all know how all of these have to work closely together to give you a true operating system. So that's 3 versions of the OpenStack architecture. So now we'll talk about the deployment, and now we see the features on the left are the same features that we talked about. But now we're going to look at the names that go with them. Portal is Horizon, Identity is Keystone, you have Glance for images, Nova for compute, Network is Neutron, Cinder for block storage, Swift for object, Trove for database, Heat, and so forth and so on. And then we have some networking capability for the management, control, and external plane. And in this system, you are going to have a controller that helps keep everything working. And then you're going to have the network connectivity, and the network, of course, has to talk to the management and control and external to the internet. And then we're going to have a compute where the virtual machines sit. And then within each of these broader functions, we lay out some of the projects, right? So in the controller, it has to have the identity, has to have networking and databases and so forth. We have the networking, and then on the right, we have the compute, which would require some networking and metering. So now this is how we put the system together. We take one more view of the feature releases. And as you see them listed along the left, they were not all released at the same time. The first one in the Austin version was Nova and Swift. That was a result of NASA and Rackspace that got together to start this in 2009, and it was launched in 2010. And then for 3 versions, they added Glance, and basically OpenStack was just Nova, Swift, and Glance, right? Compute, object, and library. And then in the following years, the Epic version came and broke out a portal and the identity feature with Keystone. And then 2 more versions, Folsom and Drizzly, added the networking, which had been part of Nova. It was broken out into its own project. And then Cinder for block storage was broken out. And then Havana, which came out last year, added the automation, which is called Heat, and the metering, which is called Thermometer. The version that was released in June of this year is called Ice House. And remember when we looked at the portal, there was a video you could watch on what's in the Ice House version. And these gives you the date and another view of when the feature functions of the project were actually released. And you can see that Juno is coming out in November 2014. It will be released at the OpenStack Paris Summit on November 4th. And members of our team are going over there. HP has got a large presence, and HP has given a lot of presentation as the Juno release. And then you can see at the very, very bottom, Kilo comes out in next April.
So let's
And then these are some of the distributions, and I think, Matt, this is where you want to sort of talk about, let me just go, yeah, you're going to talk about some of these slides, Matt.
Yeah, there
We
was
had
a
a
quick
question.
question. Sahara is MapReduce.
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 I didn't hear the question.
There was a question about what is Sahara that's coming out. Sahara is MapReduce.
I'm sorry, can you get closer to the phone?
Yeah, sorry. Sahara is MapReduce. It's that's what they do when they do a lot of the big data stuff, Hadoop and things like that. That's how they process service. MapReduce is a service.
I apologize, Matt, you're going to have to take that one because I can't hear it clearly.
Yeah. No. Does that answer your question?
It does. Thanks.
Okay. Okay. So, did you want me to take over now?
Yeah, go ahead. And you just tell me, we're on slide 20, you just tell me when to switch slides.
All right. So this you'll see, I wanted to talk about distributions because one of the things that's really interesting about OpenStack is pure, plain Jane OpenStack. And I'm going to talk about what that is in a minute and what's the difference from a distribution when I get into what we have. But you'll see there's all these different companies not only contributing to it, but they're producing distributions. Now, this is something you can take, you can install in your own servers, your own hardware, your own system, and do something with it, right? So if you're an ops organization, an IT organization with a company, like one of the auto manufacturers or a tier one supplier, you can take one of these distributions, some of them, you'll have to purchase to get the support contracts and things, and you'll run this on your own hardware. And so you'll have a cloud, right, your own data center, you can use the public one, I'll talk about in a minute. But if I write an application that says, okay, my software will say go create servers and use these, use these clients' images to use on those servers, or store stuff in blob storage, and I wrote something to work with Helion, and then I take it over to IBM or Red Hat's distribution, the APIs are the same for these, so it's portable. My application of my software is portable. And so we talked about, a little bit before about how in mainframes everything was proprietary, the whole stack. If I go write an application that uses it, or I get a third-party tool designed to work with these, the APIs are the same across OpenStack, so they'll work in any of these. And so there's that portability. And what they need to get, can you go to the next slide, please? And so you get into this idea, we talk about public clouds. And so I've got a distribution, and then there's public clouds all over the world, and these are some of them that are there today, and then there's more that are coming. I can actually take an application and go with what's the hybrid mentality, and have it run in, say, a private cloud from HP, or a public cloud that is, in a country HP doesn't even service right now, that meets their laws. And the application's portable, and it'll go multiple places. It doesn't matter, because the APIs are the same. And so that application portability, in addition, is one of the reasons that OpenStack is becoming so big. If anybody follows what's been going on with the NSA, one of the interesting things that I caught was Brazil was unhappy. So what are they doing? They're building their own government cloud based on OpenStack. So when you need a go-to technology, where do you go? OpenStack is the name of that. But there's a reason to go to distributions, which is why everybody's doing it. There's a reason, all the companies. Can you go to the next slide, please? And so I'm going to talk about Helion and why it even matters. And so Helion's a brand within HP. And it's a brand of, we're taking the industry standard cloud stuff that we talked about. OpenStack is becoming the main name in cloud. In fact, we recently bought Eucalyptus, one of the other cloud companies. And we're finding that, there are a number of cloud solutions out there, but there's everybody, you saw the distribution list, everybody is getting behind OpenStack. It's a standard for the APIs, it's a standard for the technology, it's one thing we can all get behind, and it's becoming quite dominant. And then we're taking and we're adding the story for it. We're making it enterprise grade. It's an open source product, it's an open source project or collection of projects, but enterprises want something more. There's this extra layer, and I'll talk a little bit about some of those in a minute, that they expect, and one of those is even support. So, we've got the support contracts because people want, if something breaks at midnight, you want to be able to get somebody on the phone to fix it. And with an open source project, you can't do that, but that brings in part of the stuff that's enterprise grade. And of course, we're going to make it work with all the rest of our stuff. HP's got a lot of hardware. We are a hardware company, and it's going to work across all of our hardware. And so we took the industry standard stuff, we are adding the enterprise layer and all the extras, and that's the HP's brand. We're going to make it future-proof, all those nice things you can see, and you can read the bullets yourself. So can you go to the next slide, please? Thanks. So I like to think about OpenStack like a Linux distribution. Has anybody ever created their own Linux distribution? Play with it, but it's not an easy thing, because what you really have is you've got Linux. Linux is really just the kernel. And then every Linux distribution on top of that has the user lane, which is usually the GNU user lane utilities. And then you've got additional packages. And those additional packages, if you want an Apache web server, that's an additional package. And then you've got opinionated config to make all of that work together. So when you go get a distribution like Red Hat or Ubuntu or any of the Linux distributions, you actually get a whole lot of different things that go and work. And if you want to build this yourself, your own Linux distribution, you've got to fill in all of these pieces and go out and get them yourself, which is why almost nobody does it. I asked this question when I was speaking on Friday. One person in the room raised their hand. I was surprised that many. It was a room of like 40 people, and one person had done it, and he was really interested. Nobody else did it, and there's a reason everybody uses it. It's not easy to do. It takes a lot of time. Can you go to the next slide, please? And so when you look at just pure OpenStack, what pure OpenStack does is it kind of brings in the kernel and the user line. It brings in the shared services needed to operate a cloud that everybody needs to work with for all of these related projects that you can stand up and opt into. And then it brings in all of the different projects. So it kind of gives you, a kernel and a user lane. But for most people, that's still not enough. You want your additional packages, you want opinionated config that makes everything work together seamlessly. You want a full operating system, not just some parts. Can you go to the next slide, please? And some of these parts are really important. Logging, DevOps, security. Is your setup actually secure? Or do you have, everybody's getting hacked these days, right? And I read about another one today, another store chain got hacked on the point of sale units. You read about all these things. Do you have the security out there? Do you have a system to log and to monitor those logs for things? Has it actually been reviewed with a threat analysis for somebody to see, you're leaving these ports open, you should close down? Is that whole thing checked out? Do you have ops? Because, there have been major bugs, things like Heartbleed, and, they're getting these marketing names now. But these big things have happened that are real security bugs or just software updates. Is there a method to do that? Or do you have the tooling to do those things in place? If you're building it yourself, you have to supply all of these different areas. But if you go with the distribution, that's where they fill it in. They fill in the config to make it work end to end. We fill in all of these different pieces to give you the full picture, all the way from the basics through all the stuff that takes it from being a project into being something that you can deploy and trust that dots all the I's and crosses all the T's. Can you go to the next slide, please? And so here's some of the things, right? So what's in gray here is what you're going to get in OpenStack, or what you're going to get in the blue is a lot of the extras, except, like host Linux. That's something you get. A lot of these things are built into OpenStack. Identity services, that's the Keystone project. Compute is Nova. You can see that. And yet you see some of the things HP added. We added things like infrastructure monitoring. We'll monitor stuff. So if it breaks, if there's a problem, you'll know about it. Metering is an interesting thing. Metering and billing, if you actually need the billing angle. To see what are people using. Do you need quotas? How are departments using things? You want some of those extra things. A template repository. There's things in OpenStack that you can have templates for. And we're going to get templates. It's not just you have a system to manage them. You have things out of the box. The admin dashboard and designer. And even when you get into deployment, we've got deployment modeling, because there's different ways you want to model your deployment and put it together, right? There's different ways you can do these things. You don't have to figure it out on your own and get the text files and map stuff to servers. We're going to make that easier. And so these are just a whole bunch of the different add-ins particularly on OpenStack that we give to kind of round it out from a collection of a bunch of projects to something that you can go install in a data center or install around. Yeah?
So you said what's in blue is what HP is offering.
This is part of the HP Helion.
As far as the monitoring and metering, if you are using the OpenStack platform, are there other, I'm sure there's other OpenStack solutions to provide. Do they provide that, or is that?
No. So HP's philosophy behind this stuff is to go with OpenStack. We don't go with our own dashboard. We go with OpenStack dashboard. We want to give our customers OpenStack, but we want to enterprise it. So where we're filling in is where OpenStack doesn't have it. If OpenStack had it, then we wouldn't be filling in, we would be using that. And if it's a place where the OpenStack community is interested in it, we're actually very willing to contribute it back. And we've open sourced and released whole software packages to the community to not just have our own thing, but because it's really good upstream. We spend a considerable amount of time working on these different parts, contributing our time to make them work. But these are places where either they're not something the OpenStack community is interested in, because you can use it for a lot of things. Not everybody wants to have a distribution to go install in their data center. Some people want the vanilla, and so OpenStack's not trying to be opinionated there. Even times where we wanted them to be more opinionated in the past and say, why don't you pick one? Like, no, we're going to leave this up to the people who want to. And so that's where we're filling in the blue is the
So where does the applications set in this?
This is the infrastructure view. This is not going to give you the view of the applications. Your applications, if it's running in the cloud or run on compute services, this is the stuff that helps you run the cloud itself.
Okay.
Okay? Can you go to the next slide, please? Okay, we'll get into some more views. So here's where you'll see some more things. So one of the ways that we work here, and this gets into some of the strategy stuff, is we've got HP, OpenStack is a distro, and certified plugins will run on HP and non-HP hardware. And we're going to do this, but we're always syncing up with the distributions on OpenStack.org. So we're trying to keep the code at a good point, but we're grabbing it at a release point and making sure it's tested, it works across the board. We're grabbing the open source code and testing it. But then you get into HP Helion OpenStack here, because this is our process of working with the OpenStack code and adding in the extras and making sure it works everywhere. We've got the distribution and this, which we talked about, but we also have things like the developer, okay, this is wrong. It's actually the development platform, not the developer platform. And it's Cloud Foundry based. Do you guys know what Cloud Foundry is? All right. Does anybody know what Heroku is? You've heard of it. So this is something that's built on top of it, which is, it provides a platform as a service. So say I'm writing a Python app, and I can take a config file and I can say, give me Python 2.7, give me MySQL, and I want to deploy my app into that environment. I just write the Python app. I don't have to worry about the server, the operating system. I don't even have to worry about spinning up a VM. I just say, push it out there, and all of a sudden it works. Because it's a platform as a service that goes and does all that work for you. Manage the operating system, make sure Python's installed, and make sure everything's ready for you, and it's configurable. So I can do it from Python, PHP, Go, any of these, Java, whatever language.
So it would be the equivalent of my JCL.
It's different. It's different. I'm trying to think of a good way to explain it.
It's a script. You said it's a script, right? That goes on and push.
No, it's a config file because it's a platform. The environment takes the config file and stands everything up for you. It's not exactly a script. It's a little different, but sort of. And so it's Cloud Foundry based. And so you can consume either compute where your applications will run or platform as a service, and that's where your applications end up running, and that's where your code ends up executing in one of those. Next slide, please. And so you've seen kind of what Helion looks like, and you'll see Helion is also a product family here. There's Helion OpenStack, Helion Development Platform. We'll be, not yet, but we'll be pushing HP software through the platform. So some of the HP software proprietary products that are in OpenStack that complement it will be made available through it. There's cloud systems. So if you actually want to just buy a hardware device that's got the whole darn thing on it, cloud system. So you can get it as software and so on your own system. You can get cloud system. We do managed private cloud, where we'll manage it for somebody. Virtual private cloud, and there's also the public cloud too. So HP has a public cloud, and the whole idea is everything just works across the board. You want hybrid, you want just OpenStack running your own environment, whichever way. We're trying to give an end-to-end picture where it all works together. And yet it's still based on open source. So if you do decide to leave us or come from one of our competitors, the APIs all work. So your stuff can move from one place to another. It's portable.
So, say for instance, I am the owner of Macy's. I'm the president of Macy's.
Yeah.
Why would I care? What is this going to do for me?
What is it going to do for you?
How would I use this?
There's a couple of different ways that you can use it. One, if you run this across your data center and people take advantage of the clouding scale abilities, to spin up servers on demand and tear them down when they're done, you can actually do your workloads on less hardware and get savings. Because you don't deal with everybody's peak load, you deal with your organization's peak load, which ends up being less hardware. So unfortunately, we HP sell less hardware, but that uses less power. It's not really that big of a problem for us. And then it also gives your people who do development the ability to try things. And this is a huge win, because your developers can say, hey, I want to try this application, and I want to tweak it for maybe our production one, and I want to test it at scale, I'm just going to spin up a whole bunch of servers, and I'll try it out and see if it works, and when I'm done, I'll get rid of it. And you can test and iterate. You know, one of the things that's happening in software development is it's speeding up the ability for people to make changes. And this is one of the enablers of that, because you need the environment to run your software in, even at scale. So you can say, I want 50 servers to go do this thing, and you run it, you do it, when you're done, you take it away, and somebody else can go do that.
So I run Macy's.com, where I have, I don't know, 2 trillion customers from all around the world come in and buy stuff. And
Yes.
so how does this help me do that? And I'm thinking about expanding into China. With this, would this make me, would that help me meet my objective of doing that productively? Or?
Sure, because your developers are working on applications to make Macy's.com work in China. They're making changes to it, and they want to test those changes, and they want to do it fast.
Okay.
And so one of the things that this does is it actually improves development speed for developers, because I don't have to wait for hardware to be available to test it. My ability to test things and test it under real workloads and real environments becomes, it just goes quicker.
Okay, so what about the production environment? How will it support my production environment?
It still comes down, again, we talked about, hardware doesn't matter. It does come down to the hardware underneath it. At the end of the day, how much hardware do you have that this cloud sits on? And you talked about Macy's.com, which is an interesting example, because you need PCI compliance and all of these other things involved too. But it just isn't in general thing. It still does come down to how much hardware you have underneath it. But it lets you manage the hardware more easily. If we talked about scaling the bursting model. Say you brought, all these, you opened up in China, and all of these people decided, hey, I'm going to rush there and start buying stuff. Now your servers come under load, right?
Yeah, we have a sale.
You have a sale. Your servers come under load. Well, you don't have a server farm running Macy's.com. That's your worst case scenario. You have a server farm with Macy's.com running what are people using now. And then you get a whole bunch of people come, the system detects a heavier load, it automatically adds more servers and scales up.
Okay.
And then when those people are gone and the workload comes down, it detects the workload has changed, there are less people there, you can get rid of production servers because you don't need them. You scale on demand.
The perfect example with the holidays coming.
Yeah.
PC.
And this comes with Amazon. The cloud came from Amazon because Amazon had to take, for their data centers, their worst case scenario for the entire year and have that in their data centers. That's the Christmas season, a couple of days of the week. And now you go to the middle of June where everybody's outside having fun, and their servers are sitting 90% idle. 90% idle. What do you do with that? Oh yeah, well at least the other people that run their workloads on it, born in the cloud. Because if we're not going to use it, somebody else can use that capacity to last. And that's... So, next slide. So this talks a little bit about the software services we have. We've got the HP Helion platform. There's the OpenStack and development platform, 2 different things. But we've also got solutions and professional services because part of meeting the needs of the enterprise, the Macy's of the world, is we've got to have the full portfolio. You can't just have the software. We need professional services so we can help people educate them, teach them how to use these things because for a lot of organizations, this is a game changer in the way you do things, and we need to help people do that. We've got a public cloud because you want to do hybrid. You want to have both, and sometimes you just want to run things in the public. You're not going to run Macy's.com out of your own data center necessarily. You'll want to run that distributed different data centers in the cloud around the world. Because this just doesn't need one data center. It can need multiple places all over. You want to deal with automation of things, conversion infrastructure. So maybe you develop your updates in your private cloud, and then to run them in production, you move that to a public cloud. You need to automate all of that stuff because when you deal with hundreds and thousands and tens of thousands of servers, you can't manually control everything. You need to automate. And so this is kind of the portfolio of things that we do. Next slide.
You said next slide?
Yes, please. Because I think it goes back to you. All right.
All right. Beverly, how are we doing on time?
We are doing really, really good. We have at least another 20 minutes.
Oh, very good then. So I will go through this. Okay, so you did see a little bit about professional services on the previous slide. On the circle slide with the pie shapes, it was the inner blue circle, and on the previous slide that Matt just covered, it was on the bottom right-hand side. And the reason that we talk about professional services is that we have come to see that many enterprises have the need and are in the process of using professional services to help with their cloud journey. In the discussions with clients, they have people who have read and studied and know about, but they don't have that comprehensive knowledge that we can leverage from the broad HP. And so they tend to pull us in, so you can see that there's only a small percentage at the bottom that have never used or don't have any plans, but the biggest chunks is in the blue on the left-hand side, that they are likely to use it. On the right, you see that enterprise clients purchasing or considering purchasing cloud computing services with professional services is about 74% of the environments polled. And when we talk about professional services, I've had the privilege to work over the last few years with the professional services team. We started out back in 2013 to bring together all of the existing cloud services in HP and consolidate them into the 7 service sets that you see here. And these 7 service sets are presented to you in the 3 major phases of your cloud journey. Your cloud journey should always start in the advisory portion, considering what you need to do, and so that's the advisory service and the strategy service. And then we have that middle phase, which is called the transformation phase, as you're actually doing the work. We don't even have enough time to talk about the type of work that's needed to do to move some of your legacy applications that were not built with a service-oriented architecture, and the work that is needed to transform those applications into a service-oriented architecture and have them be suitable for cloud. But there is a service that has a bunch of tools that can help you with that. And then there's multiple design services, because not only is there the technical design of your infrastructure, but you need to design all your supporting operational processes and procedures around supporting this new cloud service model, which is a lot more elastic and open, responsive. And so the design service set has multiple designs that you can get. And then when we look at a company like HP that has a broad portfolio of cloud services, we need to have a broad team that can implement all of those services. So not only do we have OpenStack implementations we can do, but we can do virtual private cloud, right? Where we can sit a physical server in a data center and you can access that physical server, but it's off-premise. Or you can consume your virtual cloud from ECS, Enterprise Cloud Services, and not have any of the capital expense of owning that hardware. And when we have that type of broad portfolio, we need a broad set of implementation services, which is included there. But then, after you've completed the 2 services in the advisory phase and the 3 service sets in the transformation phase, you need to run it, you need to operate, you need to manage it. And we are fortunate to have some operation services that can show you some of the best-in-class, most efficient operation models with, the highest level of SLAs that is suitable to your organization. And then you have to have some education of to bring your traditional teams into the cloud operating environment. And we provide those services to train your people in advance, as well as to have ongoing training as you optimize your cloud environment. So those are the 7 service sets of the HP Helion OpenStack professional services. And then what we see here is one of the roles that we can play. As you look on the left, we just talked about the advise, transform, and manage services, but they can help you as you start with a simple, well, I don't want to say simple, but as you start with the community version of OpenStack, which is in the middle here, and which is very closely linked to the OpenStack organization, and we can help move you over to the commercial version. And the professional services team will be there to help you along that way, wherever you are in that journey. Here's a little more breakdown of some of the specific actual services that the professional services team for OpenStack offer. In Advise, we have an acceleration service and an assessment service. In Transform, we can do the design and the integration work. And then in Manage, we can give you system upgrades and optimization. Let me talk a little bit about those. One of the things that's important about the OpenStack assessment is we need to understand where you are with your OpenStack and your cloud journey. We're talking with a large internet service provider, which we all know today, and they have already built OpenStack, but unfortunately, they have not kept in sync with the community. So as we've been talking with them how we can help them, it has become clear before we can jump in and actually start to help them. We need to do an assessment of where they are, because they've built their own features and functions to support internal business needs, but haven't synchronized with the community. That assessment of where they are is important. And then as we transform, if they decide to go to an HP Helion OpenStack distribution, we need to look at which parts of the features you saw on the chart, the reference architecture that had the gray boxes and the blue boxes. We have some enhanced features available. So we need to design which one of those enhanced features we're going to put into effect. So we can do that with this statement work. And then the thing about OpenStack is because the community is always making upgrades, and we showed you the versions going from Fulson to Grizzly to Havana to Icehouse to Juno coming out now in November, and Kilo in April. Each one has additional features, and you need to keep in sync with that. So you can pull down from the community a stable version, work with it, and then send your changes and your patches back up to the community and let the community work with your changes. And then the community gets the benefit of your work, and you get the community the benefit of the community. That's called continuous integration and continuous development, CI/CD, and we can help you with that in the managed portion of your cloud journey. So those are the 3 phases that professional services can help you with. And then this is a little bit more detail on all of those, and you can see the words here. I'm going to share this deck. I think Beverly already has a copy of it, so you can read through it. I won't bore you now. And then we got about 10 minutes left, and I want to leave some time for more questions. And so this is kind of the summary that we have. OpenStack Cloud Operating System, so open source software for building private and public clouds. Thank you, Matt. You did a great job on explaining the HP Helion Portfolio. And yes, Helion is a real word. It is the charged particle of helium, so it is actually an ion. And that portfolio covers many cloud services. And the professional services team is built on a lot of solution architects that spent years building and supporting large OpenStack environments with Rackspace and with ADP and a lot of other major vendors, and they bring that expertise into HP. So hopefully you got something out of this. I know that we talked about Cloud 3, 4, 5 at the start when we talked about the basic functions of a cloud, and hopefully you have a better understanding of Helion. Beverly, I think that brings us to the end. We can open the floor to questions. If there are none, I can say goodnight. Where are we at now, Beverly?
Okay, I think we're gonna open the floor to questions. They all look like they're just dying to ask something.
Well, how does this integrate with, say you have a VMware system? How does this integrate with their vSphere?
It integrates well. Our Helion release that's coming out now actually has used some networking features for the OpenFlow virtual switch to allow layer 2 connectivity between a VMware virtual machine and KVM virtual machine. So KVM is the hypervisor in Linux. And we have a client who needs that type of capability. VM has generated their own layer 2 plugin that gives you that connectivity to KVM. It's called NSX, but it's a proprietary tool and it's a little costly. So we have developed one that we're sharing with the community, and we're working with a client to validate a white paper that we're going to demonstrate at the Paris Summit. So we work very well with VMware, and you can move some of your VMware virtual machines over into the OpenStack environment running on KVM. Matt, anything to add to that?
Nope, you covered it better than I
Okay,
could.
next question.
Well,
You look like you have a question.
No, I mean, I understand what you're saying. It's new, right? They have a plug-in that they develop a script or plug in a cartridge or something. But has it been really commercialized? I mean, is it being used commercially right now a lot, or is it?
So I think I didn't hear everything, but I think you're asking if HP Helion OpenStack has been used commercially now. Is that the question?
With the VMware solution that you was just.
Oh yeah, that is a solution that VMware has brought out this year, and some people are using it. And I don't have statistics on it, but that particular VMware solution. But that's from VMware, that's not from HP.
So the HP stuff, just so you know, we talked about two things, HP Helion OpenStack and HP Helion Development Platform. Development Platform is released on Thursday this week, and OpenStack was just released. So to say, is there commercial distributions doing a lot of stuff with this? The answer is no, because they just came out or are coming out. So that's to answer your question. This is very, very new.
Very new.
Very that new. Yeah.
Bleeding edge.
Yeah.
Yep.
Okay, awesome.
now when you're
I'm still here for questions.
Yep.
I just in your automation portion, are you using some of the tools that exist like Puppet and Chef for your automation tools?
Yeah, we actually have had some discussions with the HP public cloud people who have been running OpenStack on our HP public cloud for 2 years, and the configuration management tool that they have become more comfortable with is Ansible.
No, it's actually
we were just
Chef on the
talking
public
about with a client who has a large investment in Chef and has created a lot of the Chef cookbooks. But we have found that Ansible works a little better for us. And Matt, you probably could share a little bit more about that, right?
Yeah. So it and I can talk about this to quite a bit. We're experienced with both Chef, or I shouldn't say both. We're experienced with Chef, Puppet, and Ansible. They each have their own idiosyncrasies. Our public cloud has long used Chef to do all these things. OpenStack, there's documentation, actually, even just in the OpenStack ecosystem on how to use all of those. And I think we're shipping with Ansible, and there's some good technical reasons for that. If you went back 2-3 years ago, Ansible didn't exist, right? It's a really new piece of technology. But yeah, we're experienced with all of the above. And that's actually one of those places where I talked about there's the add-on stuff, for DevOps and things like that nature. The OpenStack community didn't want to throw its weight behind any one of those. So it's one of those places where a distribution or somebody needs to fill in because it'll play in all the ecosystems.
Anyone else?
I have a question.
Okay, good.
Hi, Jambey, Linda Dinkins, how are you?
I'm sorry, I can't hear it too well.
Linda Dinkins, how are you, Jambey?
I'm doing well, thank you.
I have a question with regards, and I don't know if it's better for you or Matt, but say for instance, what's the approach for clients that need PCI compliance in the cloud?
Jambey, did you hear that? PCI
No,
compliance in the cloud?
unfortunately, I apologize, I can't hear it.
She wanted to know the approach for PCI compliance in the cloud.
She wanted to know the approach for what TI appliance?
PCI.
Ah, okay. I'm not, I can't even get close to that one. I don't have
All right.
any specifics on that. Matt, do you have any specifics on there?
Yeah, so PCI compliance is kind of hard to get to because it goes from your hardware all the way up. And you've got to find somebody who's willing to do that. Now, if we give you a distribution, or you get it like a HP Helion distribution, it's not going to be PCI because that's the software. PCI compliance is the whole darn thing through the hardware. And so if you're going to run this yourself, you're going to have to get it certified. If you're looking for a public cloud, I don't think any of the OpenStack public clouds yet have gone through PCI compliance. Like Google's cloud hasn't even gone through PCI compliance yet. So there's, unfortunately, it's AWS and Azure are the only clouds with PCI compliance that I'm aware of. But it's something that you could do. But since our stuff's so new, we haven't walked anybody through it yet.
You mentioned one name I can recognize, Azure. That's Microsoft, right?
Yeah.
So how does the HP technology and cloud compare to the Azure, which has been out for a while? Are they going to be crying tomorrow?
Is Azure going to be crying tomorrow? They're already crying today. Yeah, I don't know if you noticed here. The computer that was able to get the audio to work, that's actually a Mac sitting there, and the Windows computer couldn't get the audio to work. They're already crying over a lot of stuff today. No, I think, I don't think, this is an area that has constant growth right now, and so I don't know that anybody is going to be making each other cry, because when I spoke on Friday, one of the charts that I put up that I found was the market growth and expected market growth from analysts, and if you look at market growth over time, and there's so much growth right now that everybody who's in the game has space to jump on board at the moment. Eventually you get consolidation.
Well, I have a hypothetical. Say you're a company that's operating with equipment from the 1980s.
Okay, that's the federal government.
And you need to make the quantum leap into the here and now. So you would send consultants in to analyze the situation at this company and then make recommendations for this type of service. Is that
In fact, one of the things that Jambey showed up there was they actually will come in and look at what you have and help you figure out. So that was one of the, they have an assessment to help you figure out what do you need and understand your requirements, because we don't just come in and say, hey, buy all our cool stuff.
Yeah.
We actually want to hear what people have to say. What do you need? What are you trying to accomplish? Because, we talk about software, there's a bunch of different configurations that can be set up in, there's different parts that you can use and need to learn how to leverage. And it really depends on your needs, your workloads, and what's going on, and that's what they do.
Now, has HP approached like the city of Detroit, whose IT system is in shambles?
That's why I didn't want to say that, but yeah.
This would be a perfect opportunity to.
I'm an engineer, I don't work with that stuff. I work on making OpenStack work, I stay away from it. I don't know.
Yeah, we don't have to put our ninjas on that.
Matt, you're the second person today I've heard mention Docker.
Yes.
Who are they? What do they do?
Docker is a containeration technology. So maybe a way to think about it is, everybody familiar with Java jars, right? You take something, you bundle it up, and then you can execute it anywhere, right? Docker is sort of like that for anything. Right now, it works just for Linux, but the organization behind Docker has just struck a strategic partnership with Microsoft to make it a package technology for even Windows stuff running Windows Server. It's going to work across the board. They're working on that now. But it works kind of in a layered approach. So you'll have a Docker file, and from that Docker file, you'll create a Docker image. And that image will maybe define your operating system, right? Or the system it's on. And then you'll have another Docker file that says, oh, I'm going to inherit from the parent, and I'm just going to have my application in there. And Docker isn't actually an operating system. It runs on, is anybody familiar with containerization technology, like Linux containers? So Linux containers, when you do with a virtual machine, you actually simulate the hardware and then you run a complete operating system inside of each VM. Look at that. Introduction to Docker. Jambey, did you want to walk through this for a minute with your slide deck?
Yeah. One of our guys just gave this presentation and shared it. So
yeah.
It's a couple of slides, so it's 24 slides, and we can't go through all of it, but there's a couple of pictures here. There we go.
Yeah, so here you see virtual machines. You have a server, a host, a hypervisor, a guest operating system, and you see you've got each of these. So a virtual machine will take minutes because you literally, simulate the hardware with your hypervisor, and then a guest operating system has to boot up in there, and then it's got its own binaries and everything in there. It's entirely functionally separate. But when you deal with Docker, you've got the container engine. What you see no guest OS, because you're actually using the host OS, and the host kernel is able to control access. And what you do is you'll get things like the host OS is in a read-only mode, and the changes end up in just your app, or the differences if you want to use a different version. So say you're running one version of Java sits in the host OS, and you want to run a different version of Java. Only that different version of Java would be different, and it can sit inside the container. So rather than minutes to boot up, you've got the host OS. It's seconds or less to get something going. And everything that defines this in the layered approach is, it's called a Docker file. It's a text file that's usually commented and pretty easy to understand. And you can define it and create images, and it's all very quick, and it's one of the new pieces of technology. A year ago, this wasn't on the scene, and now it's changing the way we look at containers.
Disruptive.
It's very disruptive.
A threat to VMware?
I don't know.
Do we determine?
So there's a deck we could go through. I'm sure we don't have enough time to cover all of this.
Sounds like we're gonna have to bring you back.
Yeah.
Well, I'm glad you find it interesting.
Yes.
Docker, it's built on age-old technology. Basically, Linux has had containerization for a while, and there have been a number of containerization technologies. And what Docker did was Docker took this container technology that was kind of, you're hooking into special things in the kernel that have to do around permissions of processes and users, and it made it easy. It made it approachable to every software developer, every infrastructure person. It made it approachable, and it made it layerable and easy to work with. It even built caching in. It basically took this whole process that had been difficult before and made it easy. And they're deciding, hey, we're going to work with everybody. We will work with Azure. You can run Docker on Linux in Azure. We will work with HP. We will work with Microsoft on making, basically they're saying, we're not going to go out there and try and do our own thing. We're going to try and play nice with everybody. And so that's why they're making something that's truly disruptive. And we're only beginning to see what it is now, because it started with...
And then they actually have a demo, so I just wanted to share that with you.
Yeah, no. It's a disruptive thing that is just now, the stuff to manage it, the ecosystem around it is just forming now. And a year ago, this wasn't even being talked about, right? So it's truly disruptive, though.
Now, is this something that you believe it may get down to the mobile level?
Docker?
Yes.
No.
No, we will never get to mobile level.
Probably not right now, no. Do you have virtual machines on your phone?
Soon, they've been talking about it. They've been talking about running virtual machines. It's got these multiple cores.
Yeah. But it kind of fills that same space. So I don't know that you'll see it there soon, because that's not its core use case. But it's being used and it's even being used in a lot of the continuous integration and continuous delivery environments.
Thank you.
Yeah.
Excellent, excellent. Thank you so much, Jambey. This has been an excellent presentation. I have learned a lot. I think our audience has learned a lot. Can we recognize?
Thank you, everyone. I appreciate your time. Matt, thanks a lot. I owe you at least a beer and probably a full dinner.
A virtual one. No.
Yeah, on the holiday.
No, we're going to do this one in real. So thanks, everyone. Thanks to folks in the audience that I know and everyone else that asked questions. Your participation helped make this a success. Thank you. I'm going to sign off now, Beverly.
Okay, thank you, Jambey.
Okay, good night.
Good night.
And if you guys have more questions, I'm happy to keep talking about this stuff. I don't know all of our sales approach or professional services. I'm one of the engineers who works on this stuff, but I understand a certain amount of the technology stuff.
From a sales approach standpoint, it's all going to start on the services aspect of it. I mean, do the assessment, try to find out where people are in their journey, and pick your point where you start and where you go.
Now, how would you get involved in OpenStack? Say you want to get into it.
So OpenStack's entirely open source. So when they talk about companies contributing to it, the reality is any individual person can just go get started. Go to openstack.org, and there's guides on. Unfortunately, off the top of my head, I can't remember. But if you go to openstack.org, and I know wiki.openstack.org, the wiki, there's actually a guide that says, you want to stand this up, you want to contribute to it. Here's a step-by-step guide on where to get involved. And that's how I actually got into it. Even though I worked at HP, I said, no, I'm going to start contributing to this stuff and getting involved. I went to the OpenStack step-by-step guide and just started walking through everything.
So how long, you said you can do this, you can set up a cloud in a matter of minutes now.
Oh, to stand up VMs in the cloud, you can do it really quick. To stand up a cloud takes a little bit longer.
Like how long?
We got a new GM, so HP recently purchased Eucalyptus, and the CEO of Eucalyptus took over as being the GM of Cloud. He stood up Helion OpenStack in something like 96 minutes by himself.
Oh, so this is something that we could possibly have a workshop and do.
Yeah, so you can get Jambey to come in and teach you all this stuff.
I mean, realistically,
Yeah.
is that something that with the right equipment and the
So-
right skill set folks could learn
Yes,
how to do it?
and there are guys who are doing this in certain parts of the country, even this week. Like one of my cohorts is doing it in Chicago on Friday, because they're going to go do that, and they're actually going to walk through standing it up and helping people see that. So there's nothing, I haven't seen a lot about Helion or OpenStack in Metro Detroit, but in some of the other cities where there's a big tech thing, they're having meetups where they talk about it. They're having things where they show off installing these things. So yes.
Yeah, I guess it depends. Like our big user would be like Quicken Loans, so we have to wait for them to migrate over to that system.
Migrate over, and I think they use, I'm not sure, but I think some of their stuff's in AWS and some of the other cloud technologies they've been doing. And a lot of the stuff when you get into banking and money, it is locked into data centers, and they're kind of tight about that. Security and money, and there's a lot of federal regulations around that stuff. PCI compliance is one of the easy things they have to deal with.
You're seeing some of it in the automotive space right now, but it's more in the form of a private cloud.
Yeah, and that's where Helion comes in handy, because you want to stand up a private cloud. That's where we can ship you the bits to do that. And for somebody like an automotive, that's a great example, because you want to run a simulation on a design, get a bunch of resources, run that simulation, drop them back into the pool so somebody else can do the same thing. And a company like GM or Ford can use us over all hardware.
I mean, right now, that's outside of that. Have you really seen other large companies use it? I mean, for production purposes, because I know a lot of companies, like I said, they only have their private cloud, use it for QA/QC.
Yeah, most of the stuff that I've seen has so far been public cloud usage, and a lot of companies are using. A lot of big companies use public cloud. A lot of it. It's not unheard of for a big company to have a product that runs in a public cloud that uses. Are you familiar with AWS at all? Or
Right.
use 500 XXL machines, these big size, you know, and that's, you know, that they'll spin it out for test environment, run their tests and tear it down. And that's, you know, Fortune 100 companies doing.
This is my fun part of the meeting where I get to meet everyone in the audience. So we are so pleased to have you here this evening that we would like to give you a few minutes and tell us your name, where you work at, and how you happened to find out about the meeting tonight. Starting.
So I'm Mike Gates, I'm with Hewlett Packard. I actually heard about it from our regional cloud resource. I always need to make sure I've got the story straight, so it's always good to hear different people present it, understand what's being offered and how to apply it. My function at HP is as an enterprise account manager, so I've got a few accounts that I manage. And this is one of the key initiatives that HP has and is bringing to market this year and beyond.
Thank you. Welcome.
Thank you.
My name is Linda Dinkins. I work for Hewlett Packard as well. I heard about the meeting from you, Beverly, and the announcement that was sent out as part of the MBN, which is the Michigan Black Employee Network. My role at HP is I'm an infrastructure project manager. Program manager. I keep changing my title. To ensure that you know, the infrastructure is stood up. And I was asking about PCI compliance because I'm starting to see the need for that in some type of cloud environment from our clients.
Tamara Poole, program manager at Ford, working in application development for supply chain services and manufacturing IT. Heard about the meeting right through email through BDPA.
That's what we work for.
It worked. Email worked, and interested in. I hadn't heard of HP's Helion, so in the cloud services, so I was definitely interested in that, and just to get more informed information about overall cloud services and so forth. So enjoyed the presentation.
Matt Farina.
Yeah.
I actually heard about this from an internal mailing list at HP, just about general OpenStack stuff. In fact, when I first approached, I had no idea what BDPA was, so I got an education on that, which was great. And yeah, I've been writing code since I was a kid. My elementary school had 2 computers in it, and I had the opportunity to, when I thought I was a tinkerer, so I said, I don't want to play the games on it, I want to learn how to write the games for it. And I've been doing cloud since HP got into OpenStack, and I've done so many things between. These days, I work on architectural bits within trying to make this stuff work.
Hello, I'm Cliff Sanders Jr. I currently the Vice President of Technology Automation Committee, and I'm the Committee of all the geeks. So I try to present kind of under the hood of some of the technology. So I'm going to give a little plug for our next meeting. I'm designing, getting set up for next year. I'm going to have Monolith, who does 3D printing. So I'm trying to get set up to have a new presentation on 3D printing and give us a good overview of the 3D printing manufacturer and the software side, since a lot of these 3D printers are basically Linux machines and open source code. And the founder, Mike Mercier, he actually modified the code so his printers, even though these are off-the-shelf 3D printers, his printers can do things that the off-the-shelf can't because he modified the firmware. And currently I work with the State of Michigan Health Department in the STD surveillance area, sexually transmitted diseases. Yes. So don't let me see your names pop up. I can't call you and tell you, but I will laugh. And I handle all the network and desktop support out of the Detroit office in Midtown.
I'm J.R. Maddox, and I'm with the FBI, and I'm checking you all out.
I'm Brian McRae. I'm changing careers, and I've become interested in data processing, computers in general. And Cliff is my neighbor, and he told me about this. That's why
John Boyd. I'm a former member of BDPA, and I'm sort of in between jobs.
I'm Sharon Doss. I'm the Vice President of Program Professional Development for BDPA. And I'm also a employee of FCA, Fiat Chrysler Automobiles. This is this week. I am a Senior Project Manager in our Parts and Services IT.
Okay. We've pretty much been with BDPA for the last 10 years. Pretty much got introduced via Cliff, work full-time with the government doing various IT work, and I also teach part-time U of D Mercy, mostly doing network security and a little programming here and there.
Welcome. Welcome, everyone. I heard some people are not members yet, so let me give you a little background on us. Black Data Processing Associates was started in 1976 by Earl Pace and David Wimberly. They were at a technical conference, and they were the only ones of color. So they went back home and sat in the kitchen in Philadelphia and started BDPA. Detroit chapter was the 3rd chapter formed. We've been around since I think 78 approximately, and we are the largest minority organization in the United States that is helping to promote the careers of African Americans in IT. We have over 40 chapters across the United States, so any major city you land in, there's a BDPA chapter. The Detroit chapter is the 10th largest chapter. We meet the 3rd Thursday of every month here. Our office here is here in Techtown. We are a member-based organization, so if you are not a member, these are some of the things that you get as being a member: the networking, being able to network and advance your career technically and personally. A lot of past BDPA members, when they do find themselves looking, they do find their way back to BDPA, so we're glad to see you and welcome you. And we also are a member-based organization, so I say again, we are having a membership drive, which started October 1st, and it'll go through November 30th. And we're offering a $25 rebate off your membership. You'll pay, it's $100 for adults, $25 for students, and we're offering a $25 rebate off adult membership if you join between now and November. And for the rest of the year, our calendar, next month, we're looking to have a panel discussion on the job outlook for Detroit 2015. We had the panel discussion last year. It was a great success. HP, Blue Cross Blue Shield, Accenture Consulting were on the panel, and we had a really great turnout. So you want to look forward to that. If you're in the market and looking. I'll also mention, while we talk about job opportunities, this weekend in Detroit, downtown Renton, the Women of Color Conference is happening, and they've got a career fair going on there on Saturday from 10 to 4. So I just found out that it's free. They've opened it up and now it's free. It was $100 last week. I guess they figured it out. And so I'm sure they're going to have anywhere 30 to 40 employers down there, so you might want to make your way down there. And so those are another example of some of the things you find out by being involved with BDPA and networking. Not only do we offer the networking and those type of things, but we offer opportunities for personal development. 2015 is an election year. We have some openings for some of the board positions that will give you an opportunity for hands-on development. I mean, if you want to stay current with your skills and to go into management, this is an excellent ground to start doing that with. For example, myself, the first budget I ever managed was a BDPA budget. So when I got the chance to do it in the workplace, it was it was not intimidating. So things like that, BDPA offers you an opportunity. Whatever you can think that you want to do, we have a platform that will help you do it. And if it requires money, we'll find funding, because I mean it's out there. So those opportunities available. So that's what we're going to be doing in November. We've got the job panel coming up. In December, we will have our members only meeting. So this is another reason why you want to get that discount, become a member, because we're going to have a Vegas style party for members only, which means that whatever happens at the party, only members know. And also in December, we will have our annual holiday mixer, which is an event that we host with Black MBAs, Black journalists, Black accountants. There's like 4 other organizations. We get together, we have a holiday party. There's usually close to 150, 200 people that attend that, and it's free. You usually get a sponsor for that, and that's usually free. It's a good time. So you want to stay posted for that. That'll be showing up on our website. And as we go into 2015, we'll probably do resumes development or something to do with resumes in January. We have some opportunities for, our calendar is not full yet for the rest of January. So if there's rest of 2015. So if there's some presentations that you're interested in, that you'd like for us to try to bring in, just let us know, and we'll try to bring them in. Anything else? Anything else I'm missing?
Elections for next year.
Yes.
And open
Yes.
positions.
2015 is an election year. My position will be coming up. Anthony Garrett Dutterett is the president-elect. He was here earlier. He'll be moving into the presidency in 2016, but in 2015 we will be electing the new president-elect. It's probably a 4 to 6 year commitment, 2 years as president-elect, 2 years as president, and then 2 years as past president. And there's a lot of benefits to taking on a leadership role like that. Get to, it's been a very growing and learning experience for me. We also have opportunities we have several committees and vice president positions that within the chapter, our membership management position. We also have strategy and planning, marketing position. So if you have some skills in any of those areas, if you just want to work on the committees, you don't want to necessarily take a lead role right away, there are some opportunities. Also, I want to mention our HSCC. One of our premier things that we do is our high school computer competition. That program will be starting in January. I think the 3rd Saturday in January they'll be starting. They'll be having their open house. Right now they're in the process of designing the new curriculum for 2015, which will also include PMI. PMI is working on the new curriculum with us for 2015, and the trainers and volunteers that work on the HSCC this year will be eligible for PDUs because of the PMI involvement. We're going to be introducing the students, introducing project management to the students. It won't necessarily be a major part of their training, but they will get an introduction to it, what it is and why it's important to them as a career, as part of their careers. So that's pretty exciting. We're very excited about the relationship we are forming with PMI to be a part of our training for the youth. That's one of the primary programs that we have for the youth. And for the adults, we do the workshops every 3rd Thursday. Anything else missing?
I believe that's it.
Okay. Please take advantage of the refreshments that we brought in. We really don't want to take anything home, so enjoy. We really, really appreciate you coming out tonight. It has been a pleasure to have you, and I hope that you learned something from the presentation. I know I did. Thank you very much.
Thank you.
Thank you.